Hello, welcome back to another video on this time the applications of graphs. You may be wondering, why do you need to know about graphs and straight line graphs? Well, they have practical, everyday, useful value. In this set of videos, you'll see some of the applications of graphs. For example, they're called conversion graphs. And in this case, they're converting. You can use a graph, or you can create a graph to convert US dollars into Jamaican dollars or Barbadian dollars or Guyanese dollars and so on, depending upon their conversion rate. And you can plot the graph, it's a straight line graph. So the graph shows converting US dollars. You can read it off the graph very easily. Let me lock this so I can show you more clearly. You can very easily calculate the exchange rate using this graph. And since the exchange rate changes continually, these actual rates you see on the screen here now may not be valid for this year, 2020. But the whole idea is that you can create conversion graphs to quickly convert US dollars to any currency, Jamaican, Guyanese, Barbadian, Trinidadian, and so on. So this is how you do it. If you have 4 US dollars, it meets the graph there, so you can read off now from there, straight line there, it would be, the conversion rate would be something like that there. So 4 US dollars would be around 350 or 60 or whatever Jamaican dollars. So there's a practical value in understanding straight line graphs and their application. Let's look at another example. This time we look at the example as it refers to motion. Here in this case, we have a distance time graph of a car. The distance, here on the y-axis, we plot the distance in meters against time in seconds on the x-axis. So this is a distance time graph. Now the gradient of this graph gives the velocity or the speed of the graph. Now the gradient between in the first 10 seconds shows the velocity or speed the car is traveling at. Here, from 10 seconds to 30 seconds, the speed or the velocity remains constant, and then from there to here it increases like that. Now the gradient is steepest from A to B, isn't that so? This is steeper than that, this line here. This line here is steeper than this line here. So this is when the car has the greatest speed from 0 to 10, greatest speed. The gradient, any point along this line here, the gradient any point along this line here is 0, so the car is not moving, the car is stationary. So that's how you can use a conversion graph, this time a distance time graph, to determine the gradient at the speed on any occasion. Let's look at another example. In this graph, the area under the graph, remember the graph That's the graph there, there. And the area in gray is the gray areas, the area, the shaded area on the graph shows opposite, shows the distance traveled. The area shows the distance. The gradient of this graph gives the acceleration of the car. So from reading from this graph here, the acceleration there is pretty steep, 0 to 20 seconds. And from 20 to 40 seconds, the car has a constant speed. And then from 40 to 50, it has a constant deceleration. From 40 to 50 seconds. And then here, 50 to 60 constant deceleration there. So those are examples of the applications of graphs to everyday situations. Distance time graphs, acceleration, conversion of one currency into another.